results from projects that we have been working during the last years, especially with some colleagues from the Czech Republic here as well that follow also my presentation. So as it was said, this is now in the context of DataBio project, but this is also coming from a previous project that was very well known, that is called Foodie, that just finished at the beginning of this year. So I will tell you a little bit of our experiences of how we started to go into the direction of publishing data in agriculture domain. Okay, so I will start just with a quick motivation and highlighting the context of farm management, where you can have a many different set of stakeholders that are basically doing and performing, conducting multiple activities, managing a lot of varieties of data to many different applications. So at the end, it's a very complex ecosystem there. And one of the key challenges, of course, is how to integrate and combine these heterogeneous data sources in a way that can be used to make some economical sound decisions. So this is one of the starting points of different projects in the European context. So as I was saying, we have on the one hand SDI for apps. I was not directly involved, but my colleagues from the Czech were there as well. And the goal of this project was basically to address these issues of integration. Basically, they wanted to build a platform with open APIs in order to allow the data integration, and they were focusing especially in the context of Inspire, Copernicus, and some other open initiatives. Similarly, more or less at the same time, there was another project running in parallel that was called Foodie. In Foodie, we were building also a platform, and one of the things that we were addressing there was the integration of data that was relevant to the farming production in general. So, and the idea is to start really going into the direction of publishing linked data out of that. So, as a starting point from this project, then came the end of these projects and a kind of continuation that is now DataBio project. So DataBio is basically showcasing the benefits of big data in the raw material production for the bioeconomy industry. And they have different pilots. We have different pilots. One is some of them are in agriculture, some of them in forestry, some of them in fishery. And of course, as part of these big data challenges that we are addressing in DataBio, one of the important aspects are, of course, managing the storage, querying of big and various data sources. And how can we integrate all of these variety of these data sources? And the idea, or our goal here, is just to use linked data as a federated layer. So this is the context of the projects. So coming to the linked data, as we have seen, is our focus here. Well, we have seen, of course, that there is an increasing amount of publication of linked data. It's becoming a very popular way of publishing data on the web. This has, of course, many reasons, right? Like, for example, it improves accessibility of the data because it allows not only humans but also machines to understand and use this data. So you can easily find, reuse, and integrate this data. That's one of the most important benefits of using big data. But at the same time, you can also discover more interesting information because of these links, this technology of linking data. So you can actually find many more interested. You can enrich your data with information from other sources, and it will become much more interesting information at the end. So if we see, for example, the current state of the Linkedin Open Data Cloud, which I think that the latest one was from August this year, this is more or less the picture over there, but if we go into details to see what is the coverage of this data, I mean, we can see very large data sets are cross-domain. We know very well, for example, like Wikipedia, Freebase, and those kind of cross-domain data sets. But if we want to go to specific domains, the coverage really varies, right? So there are very good examples like geographies in government, bioinformatics, where you can see a lot of data sets there. But what about agriculture? In agriculture, we have a specific thing. So we can see, for example, interesting examples about the Agris bibliographical records. Of course, we have AgroBook, as we have also seen in many different presentations. But these are thesaurus. These are classifications, right? There are others like NAT and so on. But basically, what about the farming data itself, right? So this is something that is still missing there. So I am going to with this introduction, to go into the process of how we did this publication of farming data. So I think that we all know what the linked data concept means, like the kind of principles and technologies that are behind. There is several steps that we need to in order to do the publication of linked data. So I will go step by step how we did it, and I will show you the challenges and the results at the end. Just as a starting point, this is an overview of the technologies that we have used for our purposes. So we used a tool that is called D2RQ for transformation of relational databases into RDF graphs. We use, of course, the RDF for the representation of the data. We use ontology, in this case, a farming ontology, providing the underlying vocabulary and relations to represent the data. In order to store the data, we use Virtuoso. To discover link, we use a tool that is called Silk. Of course, we are using SparkQL for querying the semantic data. And then we have visualization applications. One of them is HSLayer for visualization, and the other one is MetaFactory that you probably have remember from yesterday's presentation as well. So all of these technologies are here behind. Okay, so going step by step. First, what kind of data are we publishing here? This data is coming from one of the projects that I mentioned at the beginning. This is from Foodie Project. In Foodie Project, there were different pilots. The two that are more connected to the work that I am presenting here is in the one in Spain that is related to precision viticulture, and the one in Czech Republic that was about the strategic and tactical planning. So these are the two main pilots connected to this talk. So the next step, once we have the data identified, is the model. What about the model? We had, of course, the first challenge here in order to see how really, do we have any standard model for representing farming data? And this was something that we found, of course, that it was not the case. So we started to define our goals. We needed to define some application vocabulary that was covering the different aspects and category of information that are dealing or are being dealt by the farm management tools and applications. And most importantly, we wanted this to be in line with the existing standard and best practices. So we took as a starting point Inspire. Inspire because, as probably you know, Inspire is a EU directive that aims at building a pan-European SDI that requires all of the different member states to publish data, spatial data in particular, but in different thematic areas, according to some rules, according to some specifications. And this is also based in ISO OGC standards, like the ISO 19100 series of standards. So we started with this as our preconditions here, and we built what is the farming data model that originally was called Foodie Data Model because that was created as part of the Foodie project. That was based in the Inspire specification for agriculture and aquaculture facilities. This is one of the thematic areas addressed by Inspire. So we took this as a starting point and then we extended to cover all the specific aspects that we found necessary to represent the data. And of course, all the information regarding geospatial data is also in line with the Annex 1, which is about geospatial data in Inspire. So, at the end, this is the core of the model. You can see on the right-hand side. So it's not so big because we didn't want to have a unique solution for everything, right? So we understand that things need to be modular because at the end you will need to have some specific thing depending on the application or the context that you are going to be applying this. So this is the core that can be easily extended for specific applications, and that's what happened actually in Foodie because we had this core used by the pilots, and then they were creating some extensions for their own applications. So the model itself is defined as a UML model. It's based on XML standards, and the most important thing to highlight here is that this model was actually consulted and verified with many different experts in Europe. So, well, this is something that Thomas can tell you a little bit more because he was the main developer of the model. But yeah, basically there are a lot of people that were taking into account feedback for the model here. So, okay, but we had the model in UML. So how we can use this for the publication of linked data? So of course our challenge was now how we transform this into our ontology. And this is something that we did in Foodie. We did the transformation of this model into our ontology. This was published already in a conference, all the process that was done. Actually, just in a summary, this was done semi-automatically. We use a tool which was called Shape Change. But of course, this required a lot of pre-processing, post-processing tasks. It was not just like you give input the UML model and you get the final ontology, everything was perfect. Of course not. We had to do a lot of things, but this tool was very useful because it was implementing some rules that are complying with the standards of the ISO 1900 standard. So, just an overview of the ontology here. This is some of the things that the tool gave us at the end. So it gives you the hierarchies. For example, future types and data types are modeled as classes. You can see the code lists also are represented as concept and classes, and then all the individuals are concept members. You have cardinalities, range, and so on. So this is the main structure. But if we go a little bit more into detail, just like three words or three main classes here of the ontology, I wanted to focus on the plot. Because the first thing that we found when we took as a starting point the Inspire model is that we needed something which is a future at a more detailed level than a site. And this is the plot which represents a continuous area of agricultural land with one type of crop species cultivated by one user in a farming mode. So this is the representation, this is the main class of the model. And then below this you can even have management zone, because in a plot you can have still, for precision farming particularly, this is very important to have a more detailed information of the production here. So these are the main classes. Another one which is very important is about the interventions. It's one of the basic future type for any kind of farming application that has some geometry and then the type and so on. So everything is open. You can see this on the web, and there is a paper that tells you about the process that we did. Okay, so now we have the model. Now, how about the data? So the next step is the data itself. So this, for this we use the tool that I said before, D2RQ, which basically what required this tool is to generate a mapping how we were going to move or represent this relational data into RDF data. Of course, the mapping itself is an RDF file as well, right? So this is some example how this mapping file looks like. So we can see, for example, what is the mapping between the classes in the database, relational database, and the classes in the RDF world. And once we have this, of course, we run the execution of this with telling them where is the original database, blah, blah, blah. And this gives you two choices. One is you can run this on the fly, meaning that you can, of course, access your data still in the SQL database, or you can generate a dump and load it in your triple store. So it depends on your needs, right? Especially if you have, for example, very large data sets, it's probably better to have a dump and put it into your triple store. In our case, we did something like this. We dumped and we put the data into Virtuoso triple store. And then, of course, in order to find some links with other interesting data sets, we needed also some tools. We used Silk for some of these tasks, but we had some difficulties in scalability. When we are dealing with very large data sets, especially with those endpoints, particular endpoints that we cannot control, it's very difficult for tools like Silk to find the links, because they have some limitation on how many queries they can get and results they can get and so on. So these are some of them were done manually, but at the end this is the kind of links that we have generated. And then, of course, how to use this data. So we have, of course, the possibility to query this data via this SPARQL endpoint. This is a Virtuoso endpoint. This is open. You can use it. So these are one example. Of course, this is for the people that know SPARQL. You can also use the faceted search endpoint provided by Virtuoso. This is some example how to use it. But most interesting is the visualization in something which is more end user interactive. So this is the map visualization. And we have two tools here. One is based on HS layer. So here, for example, you can see the management zones colored by the crop production type. And then if you click on one of these management zones, you will see information, how much was the production and information of the links and everything that is connected into the link data, right? So this is, and besides, interesting here is not that we are integrating data from other data sets here. So you see also these points over there. These are coming from another data set. This is the smart points of interest. So you can see, for example, if there is a restaurant here, there is some hotel there, interesting things that are related to the management zone. And there is also, if you see these lines over there, these are coming from another data set that is called the open land use. That is delimiting the agricultural parcels that is also in RDF data. So everything is connected here. You can see all the integration of the data here. And these are examples of once you click on something, what kind of data you can see, and so on. And the last but not least example how to use this data is through a MetaFactory application as well. So we created very simple, because this is one of the benefits as well of this tool, is it's very simple to use because it's easy to exploit the link data once you have the tools behind. So we have this entry page where you can start putting any, for example, this is a type of crop, there is Tempranillo Blanco. You will see the different types of information. Once you click on some of these types, you will see information. But most importantly, you can also see, for example, this kind of map visualization as well in MetaFactory. So this is the representation of the management zone for the Terras Gauda, that is the main player of the Spanish pilot of Foodie. And you can see, once you click, what kind of, like a short link to the production type, what was the campaign, what was the amount. Then you have links to other interesting entities on the linked open data. And you can browse more and more, going into detail using the tool itself. So these are just examples of application of the link data coming from farming data, and this is what we are moving forward now.